We have two systems here. That one's running an RTX 2080 Ti, and this one's running a 1080 Ti. They're both identical. The Core i9 is 32 gig of RAM. Basically, there's nothing bottlenecking them except the GPU. Obviously, because of the RTX features, I can't try and run DLSS on a 1080 Ti. So we're going to run in with TAA, which is the best anti-aliasing to be using at 4K. You don't really want to be using super sampling at 4K because it's just eating up memory for very little performance boost. And on this one, we're running DLSS. So I'll show you Infiltrator first. And the thing to keep a look at, feel free to look at the image quality, but also the frame rates will be up in the top left-hand corner, and you can really see the difference. So now the Big 10. Okay, hopefully these will both start at the same time. Yeah, close enough. Alright, so even at the start, and this is one of the least intensive parts of it, we're looking at almost 60 frames here and at 40, 45 frames here. And you see over time, like, depending on the complexity of the scene, this will get up to 70 or 80 frames, whereas this will sit around 40 to 50. The big thing is that, if you have a look at the image quality, you're not noticing a huge difference, but there's little bits. There are times when you'll see text come up in it. DLSS actually delivers sharper text because with TAA you're taking motion data, and sometimes that can get a bit confused, especially in this case it uses text on a transparent page. So these sorts of scenes, this is dropping to like 20 frames, whereas that's saying a good 60 frames a second. So what this is really showing us, by using DLSS, you're getting much higher performance, but no noticeable no noticeable drop in image quality. At times it might be the same as TAA, other times it looks better depending on the information being fed to the network.
Mua đi hay đợi đó về Việt Nam mua.
Hiệu ứng của ray tracing có thể đánh giá ứng của cái deep learning là có điều
Đấy thì xong thì đến phải dần.
So yeah, so if you're reviewing the 20 series cards, make sure you talk to Mary, get access to the press site, and get access to these things that I'm showing you. So, and really have a look at the image quality and judge for yourself. It's something we're really proud of, and DLSS is something that is only going to improve with time. It will make performance even greater, basically, as it's implemented. So the 2080 Ti is still the first card that really does 4K 60 FPS. Realistically, with everything turned up. Once you start adding DLSS, you're just going to get even more frames. So what I'll show next is similar thing to TAA DLSS, but we'll use using the Final Fantasy benchmark, which last time both started at the same time, but has a horrible habit of not loading at the same speed. So Final Fantasy 15 is one of those games that can cripple a system at 4K. If you turn all the settings up, put it on 4K, it's even a 1080 Ti just doesn't perform fantastically. Square Enix kind of designed the game around 30 frames per second for console, and so that 60 frames per second that PC guys want is really hard to achieve. So the couple of things to note in this scene that's just starting on the left-hand side, this is where the performance hit really starts happening because it's a big open area. One thing that DLSS seems to do really well is hair. You'll notice that TAA, the hair just seems a bit rough, whereas the DLSS actually does the hair really well. And in a game like this that's so focused on the hair, there's some pretty funky hairstyles. It makes a big difference. So if you're having a look here, like this is sitting on 30 frames a second, whereas we get 54 frames here. So it really does make a big difference. And this is a pre-existing game engine. It's something we've trained the network up for. We're continuing to train it. Final Fantasy 15 is one of the games that's been announced that will support it. The other thing to note with Final Fantasy 15, it's one of the better HDR titles. So we're running 4K GC HDR monitors on both sides here, and you're really seeing that the bright skies, the crisp blacks really comes through quite nicely. So this is a very long benchmark, but it's worth staying at least and seeing the next scene, which is a combat scenario that kind of really shows the performance boost. The other thing with DLSS, and a few people have asked about, with a lot of these technologies, we're having, we've announced games are supporting it, and there's always that question of, are game developers going to implement it? How hard is it for them? Basically, if they can already implement TAA, DLSS is really easy because we do all the work. So we have our supercomputer, Saturn V, which is incredibly powerful, and we use that to train the networks based off code that they give us. So we take a whole lot of the images and the ground truths and train up the networks and then the networks then get deployed either with game-ready drivers or updated through GFE. You don't need GFE, but you'll probably get things quicker with it. But we'll package them up with the game-ready drivers. And so these networks then just basically plug in a similar way to TAA. So, for the game developers, it's very easy because we do the work. And NVIDIA's been working on deep learning for years. We're one of the leaders in, our hardware is the gold standard for deep learning training. We have a lot of very smart scientists and developers that work with deep learning. So, they're getting some of the best people in the industry doing this work for them, which is what's so exciting about DLSS in terms of, it being implemented. On the other hand, on the ray tracing side, and I'll show you some ray trace content in a minute, the big advantage with ray tracing is that anyone who's into 3D graphics, tracing is. So it means that these people who have gone through, they're writing engines nowadays, they're working in the field, are really excited to get their hands on it. They're really excited to see what they can do with ray tracing. So that's why we've been so, talking to people at NVIDIA that work with the developers, they haven't seen this level of excitement ever. You look at Battlefield 5, they'd only had the hardware for a very short amount of time and are already doing some really amazing things. So, ray tracing is going to be a very, very exciting technology. I think will get adopted a lot faster. Obviously, we still don't have the games yet, so we're all waiting for them. But I think you guys will all be kind of blown away when you do stage one. Being able to spend some time hands-on with it at Gamescom when you were there, it really is, especially Battlefield 5 and Metro and games like that, real game changers.
What sort of performance do you think ray tracing impact?
It's really hard to say. It's, what we've demoed so far has all been demoed at 1080p. What you need to keep in mind is that's, after people have had hardware for a few weeks, when this chip came out of the factory 4 or 5 months ago for the first time, so until then there was no hardware ray tracing. So, we're still in the very early stages of seeing what people can do with it. The other thing to keep in mind is that DLSS then adds an extra level of fidelity and allows us to up the resolution without, still get that really high quality without, impacting performance. Which actually brings me really well to the final demo. So ignore this one for now, because we can't run it. So Jeff talked about the Star Wars demo that we did on DGX Station.
Can you show the temperature?
I don't have anything to show it at the moment, but yeah, we can have a look later. Yeah. So when we showed this on DGX Station at the start of the year, it was a $70,000 supercomputer workstation running at 1080p, 24 frames a second. What we've done now is we've actually, thanks to DLSS and the Turing architecture, we have a version that runs at 4K. Still runs at 24 frames a second. I can unlock the frame rate, but because it's designed as a kind of cinematic experience, once you actually run it faster, you still get some artifacts. There's some bits where her cake clips and other things. So if I unlock the frame rate, it runs at 40 frames a second. So you're looking at why RTX as a whole is so important. It's not just the ray tracing. It's not just NGX. It's this combination of the technologies that actually end up delivering something really quite impressive. So with that, I'll fire it up. Sound's not working for some reason. Yeah, so this, is you're seeing all of those things you're talking about. There's the reflections of the lighting down the corridor. There's, a whole lot of lighting bounces going on. It's smooth, it's fluid. It's really sort of showing the potential of what ray tracing can do. I don't know why this sounds like we had to move this system over for a demo earlier, so
But for the DLSS, right?
Yeah.
You don't actually need the game developer support, right? I mean, it should
well,
work for.
you need game developers as well because they still have to implement it. But
No. What I mean, what I mean is implement it, or they need to implement it. Then, but the optimization is done. Let's just say they don't have the overtime, right? It's done overtime, right?
yeah, so the actual training of the neural network is done by us. Because you need a lot of compute power to train a neural network. Because the way that works is you're sort of put in inputs, you tweak the math, and then see what comes out. And over time, you get more and more accurate results. But each time you run things in what's known as training, it takes a lot of compute power, and otherwise you're waiting weeks or months to get it done. So, by using Saturn V, we can train the network really quickly and really sort of tweak it quite fast. So, at the moment we're working with, I'm not sure the exact number of DLSS titles, but there's quite a few. Because the game developers see the potential in this. No one's going to argue with someone turning around and going, oh, we can do this, that'll up the performance and the image quality for free.
No, what I mean, sorry, maybe I should be clearer. So they implement it in the game itself.
Yeah.
But how long does it take before they, it's being optimized? Let's say they send you the sample data. How long it takes before?
I'm not sure at the moment.
I see.
I know that we're talking, days or weeks rather than months.
I see.
I can try and find out what we're sort of publicly saying about that, but obviously at the moment everyone wants it, so there's a bit of competition.
Or is it possible that
resources.
they introduce like the support for it, right, in
Yeah.
their game before it's optimized, right? Can they still benefit from the?
No. So the nature of neural networks is that you need to train the network. So there's no. One day we might have one neural network that will just recognize what games should look like and be automatically able to do things. But for now, it needs to be trained against each game.
So basically, it recognizes the game, and
Yep.
and it fits the optimizations
to that
to
game,
the game.
to that
Right,
title.
right.
Yeah.
Okay. At least it clears it up.
So how it works is that the game developer send you the data, and then
Yeah,
you
so-
put it on the neural networks to make it learn, and
Yeah.
then put the optimization back to the game on the replicas. Right?
Yeah, they send us the code for the game, and we go through and generate these 64 times super sampled images. So they're actually kind of sequences of images so we can understand the motion as well. And then we use that to train the network. And then they have to put support in for DLSS in the game, but as I said, if they have TAA, it's very simple for them. And then we send down a neural network as part of our driver. So the big thing, like training takes a lot of compute power. But you're looking at gigabytes and gigabytes and gigabytes and gigabytes of raw data to get trained. Whereas a neural network, we're talking about like double-digit megabyte. So I don't know the exact numbers. 10, 20 megabytes. Not very big for the actual trained network. And then the tensor cores are designed around inferencing, so it's designed to run the few kinds of math that the trained network needs. So all of that stuff is then done on the card. But in order to get to that point, you've got to spend all this supercomputer time to write the network itself that's then used. So that network will come in the game-ready drivers. and there's a couple of other ways to push out updates for that.
So when we have a graphic card like
Yeah.
RTX, so if a new game is released and it supports ELSS,
Yeah.
you have to get a firmware update to.
No,
it
no,
comes
it's
in
not
the driver,
firmware,
right?
it's all software.
So it comes in the driver updates, right?
Yeah, so it'll come in the driver updates or probably be pushed down by GFE as well. So
So driver update, I need driver update.
yeah,
You need to update the driver for newer games, right?
yeah, you would, but we release oftentimes a couple of drivers a month. So our Game Ready driver program is something we've been doing for a long time now, where we're always getting the early versions of the games, testing them, trying to fix and optimize around the games coming out. So it's a big thing for us. It's not just about selling a piece of silicon on a PCB, and then just washing our hands of it. The software side's really important too. We want people to buy it to game and to get the best possible experience. So that's why we focus so heavily on getting these driver updates out for the big game titles. So DLSS just plays into that because it means that we're already used to releasing new drivers for new games, and so we're just adding the neural networks into that.
For DLSS, right? The game developers, right? Do they have to pay NVIDIA? I mean, is it a free
No,
service?
we do it for free.
Okay.
Like it's to our advantage
Correct,
and to
that's
the GeForce gamers' advantage to do it. So yeah, there's no we're there to deliver a great experience
Yeah,
for
yeah.
guys that own the cards. So yeah.
Okay, thanks.
Yeah. I would assume, yeah, but not by massive amounts. But that's I guess that's kind of nature. What is effectively a very small amount of data for the benefit of the game. Because it's not storing any images, it's not storing anything like that. It's basically a bit of software designed to recognize what it's getting an output.
But you don't actually need GFE, right? But basically,
You won't
need
need
GFE. I see.
I believe that you will probably you may get updates quicker with
Quicker,
GFE,
yes.
but we're not making it a compulsory
Oh, no,
thing. You will get it with the
Every driver
drivers.
update, yeah.
Yeah.
All right.
Yeah.
Okay.
Okay.
Right.
Cool.
All right. Thank you.
That's a lot of questions.
Oh, it's good. It's been a while since we've launched something that's so complex, and there's so much to talk about with this. Like, I'd encourage you, if you were like, when you get access to press site or just go to our website. I think we made it public now, the white paper, which is 75 pages, I think. Might have gone up a bit.
It's good for bedtime reading, right?
Yeah, but Jeff's boss Nick Stanley, some of you have met in the past. Like, he's been working hard on it. There's a lot of information there because there's a lot of stuff that we've added, and it really